Hello everyone, welcome back to the channel. So today in this video I will discuss 3 marks fixed questions from the concept of coplanar vectors from the chapter vector algebra. In other words, a scalar triple product. We will work it on scalar triple product. So always remember, in your examination the 49th question will be on coplanar vectors. Coplanar vectors and 100% 3 marks 1 question bande barutte. So if you practice these questions, definitely you will get your marks. Okay. So before going to this, let me give some recall the basic concepts. So remember, if you provided with any 3 vectors a, b, c, and if you want to prove that these 3 vectors are coplanar, then the condition is that their scalar triple product, that is a dot b cross c. This is a scalar triple product of the 3 vectors. If the scalar triple product is equal to 0, then you can easily say that these 3 vectors are what? Coplanar. The given vectors are what? Coplanar. Okay. And the scalar triple product of these 3 vectors a dot b cross c, simply I can represent like this: a first vector, second vector, third vector, a b c. Or you can be written this as what? b a c also, b a c, or this is always equal to c a b. Remember this. Okay. And nothing but, and again, if your vector a is in the format of what? Vector form a1i plus a2j plus a3k, and b vector is in the format of what? b1i plus b2j plus b3k, and c vector is c1i plus c2j plus c3k. Okay. If it is like this, then the scalar triple product of these 3 vectors a dot b cross c can also be written in a determinant format. You just write the components of a vector a1, a2, a3 here, a1, a2, a3, and the second vector components b1, b2, b3, and the third vector c1, c2, c3, c1, c2, c3. So scalar triple product can be written like this. If this determinant value is 0, then definitely these a, b, c, the given 3 vectors are what? Coplanar. So this is the basic concept what we have. So let me go for this. Fine. So remember this point. And again, one more property I could say: a, b, c is there. Okay, na? In a row, if any vector is repeated, like a vector, b vector, again a vector is repeated, or you can write b vector, c vector, again c is repeated, or a vector, b vector, b is repeated. If any 2 vectors are repeated, means definitely those values always equal to 0 agutte. This is also one property, you remember this. So if you know these things, easily you can work out the 3 marks questions. Definitely. Okay. Go for the first question here without wasting much time. Look at what is given. This question is asked in 2015, 2019, also in a PU board model question paper. Read the question properly. What is given? Show that the 4 points with the position vectors are coplanar anta ide. So 4 vectors ide illi. So you write the corresponding 4 vectors and their point first. So write the given data. What is given? First vector is given, that is OA vector, position vector, that is 4i plus 8j plus 12k. Okay. And one more vector, second one, I will write it as OB, that is given 2i plus 4j plus 6k cap, and the third vector OC is provided, that is 3i cap plus 5u j cap plus 4k cap, and another vector OD is provided, that is 5ui plus 8j plus 5k cap. You have to show that the corresponding points of these vectors are what? Coplanar, alva. So I will give a small tricks here. With the OA, you write the components of OA vector. You write the components of OA vector like this, like 4, 8, 12 directly. 4, 8, 12. And OB vector in component form 2, 4, 6 is there. 2, 4, 6. And you write OC 3, 5, 4 anta ide. 3, 5, 4. And OD, I will write its points of a corresponding point D here, that is 5, 8, 5. 5, 8, 5. Write this much. Okay. Then I will tell you one thing here. If you have a 4 points like A point, B point, C point and D point, if you want to show that these 4 points are coplanar, then you first find AB vector, then find AC vector, then find AD vector, and afterwards show that the scalar triple product equal to 0. That is first vector dot second vector cross third vector, that is AD. If you show that these three vectors scalar triple product is equal to 0, then these all 4 points are what? Coplanar agutte. So my first job is to find the AB vector here. Okay na? So now I will find the AB vector. Now consider your AB vector. Okay. So AB is nothing but just you subtract OB minus OA. That is 2 minus 4. That will be what? Minus 2. Comma, again 4 minus 8, that will be minus 4, and 6 minus 12, that will be minus 6. If you don't know means, let me give a correct hint here. So already you know how to write your AB vector. Okay. So AB vector can be written as what? OB minus OA. Okay. AB can be written as OB minus OA, that is equal to OB points are what? 2, 4, 6 minus OA points are 4, 8, 12. Therefore you write your AB vector. Therefore write AB vector here. So I required AB vector will be 2 minus 4, that will be minus 2. Again 4 minus 8, that will be minus 4, and 6 minus 12, that will be minus 6. So AB components you will get. Similarly, you need to find second vector, that is AC. Okay, second vector AC here. So AC can be written as what? OC minus OA. Okay, AC vector can be written as OC minus OA. So you write the OC points there, 3, 5, 4 minus OA point, that is 4, 8, 12. 4, 8, 12. Therefore I will get my AC vector here, that is 3 minus 4 is minus 1, 5 minus 8 is minus 3, 4 minus 12, that is minus 8. So you got your AC vector here. Similarly, you need to find another vector, that is AD here. So AD vector. So AD can be written as what? OD minus OA. Okay, remember AD can be written as OD minus OA. So here write the OD points, that is 5, 8, 5 minus write the OA vector points, that is 4, 8, 12. Then find the required vector AD. So that AD can be written as 5 minus 4 is 1, 8 minus 8, that is 0, 5 minus 12, that is minus 7. So now in your hand you have AB vector, next AC vector, then AD vector, alva. So now since you have to show that if you show that these three vectors are coplanar, then these points are definitely coplanar. So to show the coplanar, you have to take their scalar triple product and show the determinant value is 0. Therefore consider AB dot first vector dot second vector dot cross third vector. So write in determinant form. So first vector components AB, you write -2, -4, -6. -2, -4, -6. Second vector AC components -1, -3, -8. Write in second row -1, -3, -8. In the third row you write 1, 0, -7. Then you resolve this determinant and show the value is equal to 0. Then the given points are what? Coplanar. So you know how to resolve the determinant. Change the symbol here. That is equal to, so plus into minus, that will be -2, and leave this first column, first row, and multiply. -3 into -7 is +21, minus 0 into -8 is what? 0. Okay. Next, this minus into -4 is what? +4, and write, leave the second column, first row, multiply this -1 into -7, that is +7. Again write minus. So 1 into -8 will be -8. Minus of this minus will be what? +8. Okay. Next, plus into minus, that will be -6. And again leave this third column and first row, multiply these two. So -1 into 0 is 0. Again minus sign. 1 into -3 is -3. Minus of this minus will be what? +3. Okay. So finally you will get -2 into 21, that is -42. 7 plus 8 is 15. 15 into 4 is 60 here. Again minus 6 into 3, that is 18. So if you resolve this, -42 plus 16 is will be +18. Remaining is -18. So answer will be what? 0. So now you got this determinant value is 0. This implies the given vectors AB, AC and AD are coplanars, hence the given points are what? Coplanar here. Okay. So this is how you need to solve. Very easy steps. Just go through this. We'll go for the next question. Hope you guys getting the points. We'll go for the second thing. Look at the question. Again same kind of question is there. Show that the given 4 points with the position vectors are coplanar anta ide. So you can work it out as I did in the previous one. Definitely you can do this. Okay. So what is there? Read the question properly. Let me work out. Show that the 4 points with the position vectors 4i, 5j plus k and -j minus k, 3, 9, 4, -4, +4 and 4. These 4 vectors are coplanar anta helidare. So just first you have to write the given data. What is given here? So given first vector you have to write, that is I will write OA vector. Okay, as I done before, OA vector I will write it as 4i plus 5j plus k. Okay. And then you write OB vector, that is a component is absent, you write 0 times of I cap. Next is -j, again -k. Then you write OC, that is 3i cap plus 9j cap plus 4k cap. Next with the fourth point, that is OD, you write -4i plus 4j plus 4k. Okay. So to make you easy, you write this point A. So you write this OA as in point format, that is 4, 5, 1. You write the components simple. Then you write OB in point wise, that is 0, -1, -1. Here you can write OC with the components I component, J component and K component, and write OD as minus 4, j component is plus 4, again k component is plus 4. Okay na? So if you have the 4 points A, B, C and D, as I told you, first you find AB, AC and AD. Okay, so first I will find AB, and you know how to write AB, that is OB minus OA. Clear? So write OB minus OA and write the OB points 0 comma minus 1 comma minus 1 minus OA point, that is 4 comma 5 comma 1, and write the vector, that is 0 minus 4. 0 minus 4 is what? Minus 4, and minus 1 minus 5. Minus 1 minus 5 is minus 6. Next minus 1, this of minus 1 is what? Minus 2. ಇಲ್ಲಿ minus 1 ಇದೆ, and this of minus 1, that becomes minus 2. Okay, so now you got your AB here, components as minus 4, minus 6, minus 2. Clear? I got my AB. Next you find AC vector. Okay, you know how to write AC. AC can be written as OC minus OA. Clear? AC can be written as OC minus OA. So OC vector, OC point is there, you write 3 comma 9 comma 4 minus OA, that is 4 5 1. 4 comma 5 comma 1, that is equal to, so here 3 minus 4 is minus 1, 9 minus 5 is plus 4, 4 minus 1 is 3. Therefore you got your AC vector in your hand, that is minus 1 comma 4 comma 3 with the components. Okay, in the next step you find another vector, that is AD. AD can be written as what? OD minus OA. Okay, so you write the OD point here, that is minus 4, 4 and 4, minus 4, 4 and plus 4, minus of OA, that is 4 comma 5 comma 1. So that is equal to, so minus 4 minus 4, that will be 0, 4 minus 5, that is minus 1, 4 minus 1, that is 3. Therefore you will get AD. So AD vector in the component, that is 0 minus 1 3. Therefore you got your AD vector. Okay, so in the final stage, just in order to prove that the given points are coplanar, consider their scalar triple product, that is consider first vector. So consider the first vector. What is that? AB. Okay, AB dot second vector is what? AC cross AD. So their scalar triple product in the determinant format. So first you write in first row minus 4, minus 6, minus 2 here, minus 4, minus 6, minus 2. In the second row write the components of AC, minus 1, 4, 3 here, minus 1, 4, 3. In the third row you write the components of AD, that is 0, minus 1, 3, 0, minus 1, 3, and you resolve this determinant and show the value is equal to 0. Definitely the given 4 points will be what? Coplanar agutte. Okay na? So for that concern, just resolve this, we'll see what will happen. You know how to resolve this determinant. Here plus into minus is minus 4, leave the bracket. Next minus of minus is plus 6. Easily you can resolve. 2, leave the bracket, and multiply with row and column wise. Okay, so what happens here? So leave the first column and first row, multiply this. 4 into 3 is 12, right? Minus 1 into 3 is minus 3, minus of this minus will become plus 3. In the next, leave this column and leave this row, multiply the remaining things. So minus 1 into 3, that will be minus 3, right? Sign minus. Next 0 into 3 will be what? 0. Next minus 2, that is leave the third column, first row, multiply this. Minus 1 into minus 1 is plus 1. Write minus sign. 0 into 4 will be 0. Simplify this. So 12 plus 3 is 15. 15 into minus 4 is 60. Okay, 12 plus 3 is 15. 15 into 4 is 60 here. Again minus 3 into plus 6 is what? Minus 18. Again minus 2. I hope something went wrong here. Please check it out. Third row, leave this column, leave this row. I think this will be minus 1 is there. Somewhere we did wrong because that value should be equal to what? 0. Just check it wherever else is there. Because of that one only we may arrive with the wrong things. Okay, so find that if you show that this determinant value is equal to 0, definitely that becomes what? 0 is there. Means coplanar agutte. Go for the things here. Minus 4 is minus 8. See here, one thing we did. Minus 4 is what? Minus 8 agutte. So look at this. This is minus 8. So this will be what? Minus 8. Okay, so then this will be what? Minus 8 minus 3 is minus 24. Minus of minus will be plus. So this will be what? Plus 24 agutte. So 24 minus 3 will be 21. 21 into 6 will be minus 126. Minus 126 agutte. And then last one, minus 1 into minus 1 is plus 1. Again minus 8 into 4 is minus 32. Minus of minus will be what? Plus agutte. So 32 plus 1 is 33. 33 into 2 is minus 66. So if you resolve this minus, this will be what? Plus 3 plus 126 and minus 66. If you resolve, you will get the answer is 0. Then the required given points are what? Coplanar. Please go through this and don't make error, because we did a damage here, that is minus 4 of minus 4 will be what? Minus 8 agutte. Not at all 0. Okay na? Don't do error. So please resort it and resolve this. We'll go for the next question, guys. I hope you resort the error there, and definitely answer will be what? 0. Hence the given 3 vectors A, B, AC, AD are coplanar. 4 points are what? Coplanar there. Go for the next. So most important, most of the time is asked one same kind of question they may ask. Instead of asking x value, they may ask lambda value also. Okay, so what is provided? Write the given data properly. First they told you the given 4 points are already they are coplanar. Look at what they have given. Find the value of x such that the given 4 points already they are coplanar. Then find the value of x. It means the scalar triple product of all the 3 vectors, whatever you are going to find, that is equal to 0. Because coplanar condition you have to write and take it equal to 0. Then find the value of x. This question is asked in 2017, 18 and 20 and 2022 also. Model question paper. We'll see this, how to resolve the things. First you write the given data. What is that? The given points A, that is 3, 2, 1, and the B point 4, x, 5, and the C point 4, 2, minus 2, and the fourth point D 6, 5, minus 1. They are coplanar. So if they are coplanar, then they are constituting whatever the required vectors are there, they are also what? Coplanar. So first you find AB vector here. First I will find AB vector. So A to B. So AB vector can be written as what? 4 minus 3 you do. That is OB minus OA madbekagutte alva. So this is OA and this will be OB like that. So just go with B minus A. So 4 minus 3. First you write 4 minus 3 is what? 1. Again components format, x minus 2, x minus 2 here. Next 5 minus 1, that is 4. Go slow, no problem. That is 5 minus 1 is 4. So now you got AB. Similarly, you find what? AC. So A with C you have to check out. So here 4 minus 3. Don't do 3 minus 4. Go with C, then come with A. Likewise, OC minus OA. Okay na. So OC is nothing but C point agate. That is 4 minus 3 you have to do. That is 4 minus 3. That is 1. Next 2 minus 2. That is 0. Again minus 2 minus 1. That is minus 3. So you got AC as 1 comma 0 comma minus 3. Similarly find AD vector. So AD means what? In a D point you have to subtract A point, right? D minus A point. That is 6 minus 3. That is 3 here. Next 5 minus 2. That is 3. Minus 1 and minus of minus is minus 2 here. Okay, so now you got these things. Once again you check out. AD means go with D minus A. 6 minus 3 is 3. 5 minus 2 is 3. Again minus 1 minus 1. Minus 1 minus of 1 is minus 2. Okay, so now you got the three vectors. According to them, since they are coplanar, find its scalar triple product. So consider the scalar triple product, that is first vector dot second vector AC cross third vector AD. So their scalar triple product is equal to what? 0, because they are coplanar, and hence find their determinant here. So in the first row you write the components of AB, that is 1 comma x minus 2 comma 4, 1 x minus 2 4. In the second row you write 1 0 minus 3, 1 0 minus 3, and in the third row you write 3 3 minus 2, 3 comma 3 comma minus 2. Okay, resolve this by taking a equal to 0 and then find the value of x. So you know how to resolve this. Change the symbol here, plus minus plus signs here. So multiply. So plus of 1 into bracket. So 0 into minus 2 is 0, right? Minus 3 into minus 3 is minus 9. Minus of this minus will be plus 9. Next minus of x minus 2. Minus of x minus 2 into bracket. You leave the second column and first row, multiply this. 1 into minus 2 is minus 2, minus sign. 3 into minus 3 is plus minus 9. Minus of this minus will be plus 9. Again plus of 4 into, leave this third column and first row, multiply this. 1 into 3 will be 3, minus 3 into 0 will be 0. Take it is equal to 0 and simplify. Here it is 9, 9 into 1 is 9. Again it is minus of x minus 2 into bracket. 9 minus 2 is 7, plus 4 into 3, that is equal to 0. So if you simplify this, that is equal to 9 minus 7 into x is 7x. Again this minus and this minus will be plus. You got 7 into 2 is 14, plus 4 into 3 is 12, that is equal to 0. Other words, 9 plus 14 plus 12, you will get 35 minus 7x equal to 0, or you can get 7x equal to 35, or else you can get x equal to 7 1s are 7 5s are. So you will get the required answer, x equal to 5. Hope you got this point. Very easy one. Instead of x they can ask you lambda, no problem, just go through the same steps. I hope you got this. Take a screenshot. We'll go for the next one. Fourth question, one more type of question here which is asked in 2015 as well as PU board model question paper. So what is they have asked? Look at, find the value of lambda if the vectors a vector, b vector and c vector are already they are coplanar anta ide. So again you have to consider the condition of coplanar. First you have to write the given data there. So what is given? First you write your A vector. So A vector is that I cap plus 3j cap plus k cap, and next you write your B vector, that is 2i minus j minus k cap, and the third vector C, that is lambda times of I plus 7 times of j plus 3 times of k anta ide alva. Since they told that these are what are coplanar, if the three vectors are coplanar, according to the condition, their scalar triple product, that is A dot B cross C, is equal to 0 alva. So again A dot B cross C equal to 0, nothing but their determinant value, their determinant is equal to what? 0. Okay, so first you write the components of A, that is I component is here, it is 1, again J component is 3, you write 3, here K component is what? 1, you write 1. Next you have to check out, that is 2 minus 1, again minus 1, that is there, that is 2 comma minus 1 comma minus 1. Next lambda 7 3, write in third row, A component, B component and C vector component here, lambda 7 3, lambda 7 and 3. Okay, now you resolve this by changing the signs. See, be careful while doing the problem. So plus minus plus here, so resolve this. First plus of 1 into bracket, leave this first column, first row, multiply this, minus 1 into 3 is minus 3, minus sign, 7 into minus 1 is minus 7, minus of this minus will be plus 7, again minus of 3 into bracket, so leave this column and leave this row, multiply 2 into 3, that will be 6, minus sign, lambda into minus 1 is minus lambda, minus of this minus will be plus lambda here. Okay, next is plus of 1 into bracket, so leave the third column, first row, multiply this, 2 into 7 is 14, minus sign, lambda into minus 1 is again minus lambda, minus of this minus will be plus lambda, that is equal to what? 0. Okay, so now simplify this, 7 minus 3 is 4, 4 into 1 is 4, again this multiply, minus 3 into 6 is minus 18, again minus into plus is minus, 3 into lambda is 3 lambda plus 14, 1 plus lambda is again lambda, equal to what? 0. Now 4 minus 18 is what? Minus 14, again here plus 14, they will get cancel, remaining will be what? Minus 3 lambda plus lambda equal to 0, or minus 2 lambda equal to 0, you will get lambda equal to 0 finally. So this is the required answer, only 3 marks here. For these steps follow properly, then go for the next question. Please do practice the same thing. They may give lambda in the first place or in the middle or wherever, just you write the components of I, J, K, first vector, second vector, third vector properly in the determinant, then only you can get the correct answer. Fine, so we'll go for the next question here. So proof ideally remember, so whenever you got the proofs, things goes different. So here is the question, and the same question is asked like this also. Look at, prove that a plus b, b plus c, c plus a is equal to 2 times of abc anta ಕೇಳಿದಾನೆ. Same question he has asked this one as, show that abc are coplanar if a plus b, b plus c and c plus a are coplanar anta ಇದೆ. Okay na? Look at, so I'll go with this one. If you want to prove that a plus b, b plus c and c plus a is equal to 2 times of abc, so before that you need to have some basic properties are here. first thing is what? They have given A plus B, B plus C and C plus A. Okay, now this is nothing but the scalar triple product you have to consider. That is equal to first vector, you write as it is A plus B, first vector dot second vector cross a third vector, that is B plus C cross C plus A. Okay, now so that is what I am trying to show here. That is equal to C first vector dot second vector cross third vector, to make you understand easily. Now whenever you got such things, just you write, resolve the inside the square bracket. Okay, first you go with the B. Okay, so here it is B cross C, here first one B cross C, B cross C, B cross C plus B cross A, B cross A here. Next you go with C here, symbol is plus, write plus C cross C, C cross C, again plus into plus is plus here, C cross A, C cross A. Okay, and that is equal to, look at, now you go with the outside things. First you target the A with A dot first one, A dot second, A dot third one, A dot fourth one. So split it. So A dot first one, that is AB cross C, plus A dot second one, that is A dot B cross A, plus symbol. Next again A dot third one, that is A dot C cross C, plus again A dot fourth one, that is A dot C cross A. Okay, now I done with A, then I will go with B here. Check out what is that. That is B dot first one, that is B cross C, plus again B dot second one, B dot B cross A, plus again B dot third one, that is B dot C cross C, plus again B dot fourth one, B dot C cross A. So easily you can split out here. Next you remember, again look at this, A dot B cross C is here. I already told you how to write A dot B cross C. A dot B cross C you can represent like this also, that is A, B and C. And one more thing you remember, A, B, C can be written as B, A, C also, or you can take it as C, A, B also. Okay, first one, second basic and the third basic. If any two vectors are repeated in this row, then the value is what? 0. Here A, B, C is here. I will write A dot B cross C, and look at in this way. Here A and A is repeated. If any two vectors are repeated, answer is 0. Here also C and C is repeated, answer is 0. In this here in this value, here A dot, again A is repeated, 0. Here B and B is repeated, again 0. Here also same thing, B and B is again repeated, 0. Whatever the thing, if any two vectors are repeated, answer will be 0, because cross product of same vector is always 0. Again C cross C, it is 0. What is left? Left is what? B dot C cross A. Okay, you know that how to write A dot B cross A. Simply you write first vector, second vector, third vector, plus what is remaining here? First, second, third, that is B, C, A. Okay, now but we need to prove that that is equal to 2 times of ABC alva. So again you can write this as A B C plus, and I told you BCA, here BCA, BAC or BCA can be written as what? ABC. Clear? So again you write that as what? Replace like ABC. Remember, ABC can be written as BCA, or you can write this as CAB. So BCA na replace ಮಾಡಿಬಿಟ್ಟು ಏನು ಮಾಡಿ ABC ಅಂತ ವರ್ಕೌಟ್ ಮಾಡಿ, that is equal to ABC plus ABC is what? 2 times of ABC ಆಗುತ್ತೆ. Hence the proof. Okay, but go slow, practice more, definitely you will get this. Okay, same question is here, that one asked like this: show that the vectors ABC are coplanar if A plus B, B plus C, C plus A are coplanar anta ide. If A plus B, B plus C, C plus A are coplanar, then their scalar triple product will be what? 0 alva. So look at this, I will show this question by using that. Look at, since A plus B, B plus C, C plus A are coplanar, then you can write that what? Equal to 0 ಅಂತ ತಗೊಳ್ಬೋದು. If this question asked in different way, if these three are coplanar equal to 0, so ಎಲ್ಲ ಕಡೆ ನೀವು equal to 0 ತಗೊಂಡ್ಬಿಟ್ರೆ ಲಾಸ್ಟಿಗೆ ಇಲ್ಲಿ ಏನು ಸಿಗುತ್ತೆ ನಿಮಗೆ? 2 times of A B C equal to 0 ಸಿಗುತ್ತಾ? Then you can write A B C, this into 2 becomes what? Divided by 2, that will be 0. So if ABC equal to 0 is nothing but what? Their scalar triple product is 0. Scalar triple product is 0 is nothing but A vector, B vector, C vector or what? Coplanar ಆಗುತ್ತೆ. That is the thing. Hope you got this point. If they ask like this, you write this one. If they told you AP, BC and CA are coplanar, then take it is equal to 0. In this question, there is no need to take 0. Okay na? So hope you understood this. So one question in a different way they can ask. In the upcoming next videos, again I will solve such type of properties again. So this will be the part 1, and in part 2 video again I will come up with some other properties which will be asked for 3 marks. Okay, hope you understood this. Repeat the video, understand it, again practice, definitely you will be getting a 3 marks there about coplanarity and scalar triple product values.